Hello students, welcome to the class. So today will be the day 22 of this JEE 40 days crash course and we will be continuing with our chapter P block elements. So far we have done a general introduction of this chapter and we have done a part of group 13 elements. So this is our disclaimer. Now today we will deal with some important compounds of boron. Okay, so that includes diboron, then borax. After that we have the boric acid, then boron trifluoride, and we will also see aluminium chloride. Okay, so this is the compound of your aluminium and also alums. So these are some things, these are some topics that we are going to cover today, which are basically the compound related to group 13 element. So for boron we have diboron, borax, boric acid and boron trifluoride, and for aluminium we have aluminium chloride and alums. So starting with the first one, which is diboron, whose formula is B2H6. So basically, diboron is formed due to dimerization of BH3 or boron. Now it is a colorless and highly toxic gas which has a boiling point of 180 Kelvin, and it catches fire spontaneously upon exposure to air. So this is the reaction for the spontaneous reaction of your diboron with oxygen, which is B2H6 plus 3O2 giving us B2O3 plus 3H2O. Next is our reaction with ammonia. So diboron reacts with ammonia to form boragine. So boragine is a very interesting compound. This is your reaction. So first your B2H6 reacts with ammonia to form a complex. Then this complex is decomposed under heat to form the boragine, which is B3N3H6 plus 12 molecules of hydrogen. Here the compound B3N3H6 is also known as inorganic benzene. Why is it named so? Because its structure resembles the normal C6H6. So instead of having a proper ring of carbon, a six-membered ring of carbon, we have ring made up of boron and nitrogen, and they are present alternatively. And to each boron and nitrogen, you can see a double and a single bond that makes up your organic like benzene. Got it? So you can see here that in view of its ring structure with alternative BH and NH group. Next, at high temperature, this inorganic graphite is opted instead of boragine. So basically they form a sheet-like structure upon further heating of this boragine, and therefore it is also named as inorganic graphite. So what we conclude from here? So first we start with the diboron. This is the first compound, and upon oxidation it gives you B2O3. Whereas on reaction with ammonia, it gives us boragine. Boragine resembles the inorganic benzene. Okay, it is similar to your organic benzene. Then we have this further heating of this B3N3H6. Now, further heating of this boragine results in a inorganic graphite. Means here the sheets that you are seeing, rather than making it up of carbon, it is made up of Bn units. So here we have written as Bn whole X. Next, what is the structure of diboron? This is something which is very important. Here you can see a B2H6 structure, and here we have two types of hydrogen. So the first one is named as HA. You can see here in the description, it is HA here and HA here. These are known as terminal hydrogens, whereas these two hydrogens which are present at bridging position, these are bridged hydrogen. Okay. Now these two hydrogens have different kind of bonding properties with respect to the boron. If I talk about the bond length here, then it is also different. In the terminal hydrogen, the bond length between boron and hydrogen is 119 picometer, whereas in the case of bridged hydrogen, the bond length between boron and hydrogen is 134 picometer, and also the angle has decreased from 197 degree to 120 degrees. Okay. Now let us talk more about the structure, because the structure is something which is very important and has a unique property. Because so far we have studied that to make a single bond, we need two electrons. Okay, every time you make a bond, you need two electrons for every bond. First time you will see that for two bonds, we will need three electrons. Okay, so if for one bond we need two electrons, then obviously for two you would need four. But here would see that for two bonds you will need three electrons to be there. Okay, and that is the reason we call it as three centered two electron. So the terminal bonds are two centered two electron, whereas the internal two or the bridged hydrogen makes a three centered two electron. Now why is it so? If I talk about boron, so boron has three electrons in total. Okay, so one should be here in the terminal H here and on the downside here. So these two electrons are involved in the terminal part. Let us talk about the leftover electron. So it has three electron. Third electron is involved here. Got it? And we have a electron from hydrogen. But what about this bond that you are seeing? This upper bond that you are seeing, it should not be involving any electron. Got it? Similarly, this boron also has maximum of 3 electrons. So how it can make the fourth bond? Basically, these two electrons. So if I talk about suppose this boron, here this boron and this hydrogen is giving the electron, but these two electrons are shared over three centers, this boron, this hydrogen and this boron, whereas the third electron of the second boron is shared over this boron, this hydrogen and this boron. Got it? Basically, what do I mean by here? So it is a type of three center two electron bond. The centers are three, but the electrons are two. And same can be said about this banana bond. Now, this specific type of bonding that you are seeing here, where we are not seeing the popular two center two electron, rather than we are seeing a banana bond, three center two electron, they are named as banana bond. Okay, you can see here that they are present in the form of banana. So the lobes look like the shape of banana. Got it? So remember, the terminal boron makes a bond with hydrogen. Sorry, terminal hydrogen makes a bond with boron as two center two electron, whereas the bridged hydrogen makes a three center two electron. Okay, why I am calling it as two center two electron? Because these hydrogen and this boron are the two centers and they have one electron, so two center two electron. Whereas in this case, the electron count is two, but centers are three. This boron, this hydrogen, and this boron. Got it? Now, due to this banana bonding, your B2H6 deficiency has been removed in a way. You know it very well that BH3 is a hypovalent compound. It has an electron count less than 8. So, to remove this electron deficiency, your boron dimerizes to form the B2H6, where the electron is coming from another set of the dimer. Got it? What about its hybridization? So it will be sp3 now. In BH3, the hybridization of boron is sp2, but here in B2H6, the hybridization of boron is sp3. Next, we have a very important reaction where your metal hydride is treated with this boron to form the MbH4 minus. Now, this kind of reducing agents are used in your organic chemistry. If you place here Li, it will give you LiBH4. If you place here Na, it will give you NaBH4. Okay, so basically this reaction is giving you a very good reducing agent which is used in organic chemistry for conversion from aldehyde or ketone to alcohols. Okay, got it? I hope this part is clear to you. Now, moving on to the next. This is also used in the polymerization process for welding torch as the reducing agent in inorganic reaction. So as I said, this M plus BH4 minus is used as an reducing agent in inorganic reaction, as well as B2H6 is also used in the organic reaction as reducing agent. It is particularly used for carboxylic acid to convert it into the alcohol. Okay, so both B2H6 and the product of the reaction of the metal hydrides with the diboron is also used as a reducing agent. Okay. Next, we have borax. So remember all the parts that we have studied. So we started with the boron, diboron, and said that it reacts with your oxygen and it shows an explosive reaction to form B2O3. Then what we saw about its structure that it has two types of bonding with hydrogen. First is the terminal type, where it is 2 center 2 electron, and the bridged part which is 3 center 2 electron. Due to this, it forms a banana bond. Okay. Then we also saw a reaction with the metal hydrides where it forms the particular M plus BH4 minus. So M can be lithium and sodium both. Okay, I hope this part is clear to you. So you have to, I think, means think about this. So there is some logic, there are some rationals, but still you have to learn up these reactions. So moving on further, next is your borax. Its formula is Na2B4O7.10H2O, and its name is sodium tetraborate decahydrate. So decahydrate for this 10H2O and tetraborate. Next, this that you are seeing right now, borax is sodium tetraborate decahydrate. The white crystalline, sorry, the white crystalline appearance that you are seeing, it is seen in most of the elements of this same group. You talk about sodium chloride. There also you will see a white type of structure. Got it? Next, this 10 molecules of water that you are seeing, it is stuck in your crystalline structure of your borax. So it has a crystalline structure, and in between, these water molecules are trapped inside. Okay. Next, it dissolves in water to give an alkaline solution. So it acts as a base here. So basically, this borax Na2B4O7 is a base. So it reacts with water to make the solution basic. Now this is the reaction: Na2B4O7 plus 7H2O plus NaOH plus 4H3BO3. So this is the overall reaction, and you can clearly see that after the reaction we have a release of sodium hydroxide, which is a base. Okay. Next, if you heat this up, then obviously first thing that would happen is the removal of this 10 molecules of water, that decahydrate that you are seeing. So that must dehydrate upon heating it in the presence of oxygen. And next, what would happen? Next, it would be decomposing to form the NaBO2, which is the glassy mass. Now, this reaction is also seen in the inorganic analysis, which is known as the borax bead. Okay, so this is that same borax bead test. So when you treat your Na2B4O7.10H2O, it forms the Na2B4O7 first of all by removing the 10 moles of water. Further, it is decomposed to form NaBO2 plus B2O3. So this B2O3 is boric anhydride, and overall this forms a glassy mass, and hence it is used as a borax bead test. Next we have this reaction with acid. So if you treat your given borax with HCl, then what will happen? It will form orthoboric acid or H3BO3. So three structures we have studied so far. One is B2O3, which is known as boric anhydride, and you also get this boric anhydride upon reaction of diboron with oxygen. Second thing that you have seen is the diboron, which is B2H6, and B2H6 is not stable, so it quickly forms, your BH3 is not stable because of its hypovalency, so it quickly forms the dimer known as diborane. Got it? Next, we are learning about this sodium tetraborate decahydrate. So this is a classical example of a molecule that holds water inside its crystalline structure. Now, if you treat this with water, it will form a basic solution because of the formation of sodium hydroxide. And if you heat it, it forms the borax bead, which is a glassy mass. Then, if you treat it with the acid, what will happen? A strong acid like HCl, this will kick a weak acid out of its salt. So this is the salt that it kicks out. Then the H plus from the HCl attacks the borate ion and forcing it to accept the proton and revert back to its parent form, which is H3BO3. Okay, so this sodium tetraborate decahydrate that you are seeing, it is formed from the orthoboric acid itself. When you treat it with the HCl, this H plus kicks out this orthoboric acid, okay, and forms the corresponding parent atoms. Now you would see white flakes of boric acid separating out because boric acid is not soluble in cold water compared to highly soluble salt like NaCl that is also formed in water. So this will be removed from the solution, whereas this NaCl will be present in the solution because we are doing all of this in water. Next, talking more about this sodium tetraborate decahydrate. What about the structure? So it has a tetrahedral unit. If you break down this overall structure and keep this cationic part apart, which is 2Na plus, you will get it as B4O5 OH4 2 minus. Got it? Now, what is the structure of this cationic part? So here we have 4 borons attached in a rectangular pattern, and each of them are connected through oxygen in between, whereas OH is connected to each boron. Okay. Next, to complete the valency, we have a negative sign here in the bottom as well in the top. Is it clear to you? So the structure is very, very important. Many times you will see questions directly from the structure regarding that how many oxygens are present as the bridged part. Okay, so if you consider here the structure, you can clearly see that there are 5 hydrogens, oxygens which are bridged between 2 borons, whereas other oxygens, the 4 other oxygens are present at the terminal part along with the hydrogen. Got it? Is it clear to you? So the structure is very, very important. Moving on to the next, we have this boric acid. As I said earlier, so boric acid, how it is formed? If you treat your given sodium tetraborate decahydrate with HCl, it will give you boric acid. Now, boric acid is also a soft white crystalline solid and it has a soapy touch and it is less soluble in water because it dissolves. Why does it dissolve poorly in cold water? Because the hydrogen bonds holding those crystal sheets together are quite stable. You need heat to break those intermolecular bonds and get it into fully dissolved. Okay, so basically here what we are saying that they are forming bonds between the molecules, and as a result of that they are incapable of forming bonds with the water. Next, it is a monobasic acid. Now this is a very important point. What does it mean? It means that it can it can accept one OH. And remember, it is a protonic acid. It cannot donate proton, but it can accept a pair of electron. Got it? You got my point? So what did I say? It can accept one pair of electron and it is not a protonic acid, means it does not act as a H plus donor. So if you heat this above 370 degree, it will form the metaboric acid. Again, how it is formed? It is formed as a result of removal of water. So if you remove water from here, so two molecules or two atoms of hydrogen and one atom of oxygen. So that will give you HbO2. So very simple. And if you heat in further, then two molecules of HbO2 will dimerize and water will be removed from it. Okay. So if two of them will dimerize, what it will form? H2B2O4. Now remove one molecule of water. So H2 will be removed and O will be removed. So you will be left with B2O3. So you can see that there is clearly a logic in the reactions as well. Okay. Remember some common reactions. Suppose if you are heating something, of course you will see two properties or two possibilities. First is removal of water. Second is decomposition. Okay. Got it? Like in the sodium tetraborate decahydrate, you have seen the decomposition. Whereas in this case, if you are heating it further, the water is getting removed from the given molecular formula. Next, we have this reaction. So H3BO3 is heated to remove one molecule of water to form HbO2. Now two molecules of HbO2 are trying to be together and one molecule of water is removed from it to form the B2O3, which is your boron trioxide. Now you are getting this boron trioxide again We have seen this in the previous part also, where you were heating your diborane, or you were doing your reaction of your diborane with oxygen. Next, talking about more this boric acid. So, if I talk about the structure of boric acid, it has a layered structure in which planar BO3 units are joined together by H bond. So, this is the structure that you can see. Here is BOH3. Okay. Now, what else you can observe? You can see intermolecular hydrogen bonding in between. So basically, one oxygen is doing an intermolecular hydrogen bonding with the other hydrogen of the other molecule. Similarly, here also you can see hydrogen bonding, and together it is forming a sheet-like structure. Got it? So this is also something which is very, very important regarding the structure of your boric acid. Next, about its use. So it is used as an antiseptic, eye wash, and a food preservative in glass industry and pottery. Remember, again, when you heat your sodium tetraborate decahydrate, it gives you your borax bead test. Okay, that glassy mass that you have seen. Next is your boron trifluoride. So, your boron trifluoride is a molecule which is very thirsty for electrons because it is having fluorine attached to it, which has high electronegativity. Now, when it hits the moisture in the air, it does not get wet. It does not just get wet easily. It chemically attacks the water instantly. Okay, and as a result of this, it undergoes hydrolysis. So, as a result of this, it is also exceedingly soluble in water, and it is collected over Hg. Next, as I said earlier, BF3 is an electron deficient compound. So, it can accept electron from the electron donor species such as NH3, H2S or F minus. Okay, hence it can act as a Lewis acid, and this is the reaction that it gives. You can see here it is forming a adduct. This is called as adduct. So here is your adduct between boron trifluoride and your ammonia. Second is the adduct between boron trifluoride and hydrogen sulfide, and third is the adduct between boron trifluoride and fluoride ion. Okay. Now, due to its electron accepting tendency, it is also used as a catalyst in a number of organic reactions. Moving on further with this boron trifluoride, it combines with water forming two hydrates. Okay, the first one is BF3.H2O and BF3.2H2O. Again, why it is forming so? Because it is lacking in water. Now, it gets hydrolyzed in aqueous solution that gives us boric acid and hydrofluoroboric acid. So BF3 plus 3H2O gives us H3BO3 plus 3HB4. Next, what about the bond length in the case of BF3? So they have a bond length of 1.30 angstrom, and they are shorter than the sum of the covalent radii of boron and fluorine. Why is it so? Because of the good overlap that is occurring between your boron and fluorine, because they fall in the same period. Okay, hence their energy level are quite closer to each other, and they are doing a good overlap, and hence their size are decreasing. So think of it in this way: if it is present without overlapping, then they would be far from each other. Now if they are overlapping in a good fashion, then that would decrease the distance between their two nuclei. Okay, talking about the bond energy of BF3, so it is very high, which is 646 kilojoule per mole, again due to the proper bonding that you see. And also it shows a sort of back bonding. So basically your fluorine atom is capable of donating its lone pair onto the boron because of the proper overlap it is doing, and hence due to this back bonding, their bond is very strong, and we need a higher amount of energy to break it. So based on modern explanation, the double bond is delocalized. So this is the thing that I was talking about. Okay. So fluorine is basically donating its electron back to the boron, and this is donated in a one by one fashion, or you can say it is being delocalized. These electrons are delocalized. This is the resonance structure of the three BF3 that are possible according to the fluorine which is donating its electron to the boron. Next, so these various structure of BF3 molecules all involves p-pi back bonding. So why it is called p-pi? Because the electrons which are present in the pure p orbital of your fluorine are donating its electron to the pure empty p orbital of the boron. Okay, you know it very well. Upon excitation, one p orbital is left as an empty orbital, and there your pure p orbital of fluorine is donating its electron. So it is a p-pi back bonding, and this thing is used as a building block for production of other boron compounds as well. Next, we have aluminium chloride. Now, let us talk about this aluminium chloride. So, aluminium chloride is deliquescent, means it loves water so much that it does not get wet. It absorbs moisture from the air until it literally dissolves in it. So, it is very water lovable. Next, it is covalent and soluble in organic solvent. Although your aluminium is a metal, but due to its metalloid nature, means it is in between the metals and non-metals and not completely onto the metal. As a result of this, it shows the property closer to your metalloids, and hence it can form covalent bonds. Now if it is forming covalent bond, means it is non-polar in nature in some sense. Okay, and what is the reason behind it? The low electronegativity difference between aluminum and chlorine. So as a result of this, it is soluble in organic solvents. Okay, now if I talk about the next part, then this is the structure part. Structure, for every time you see a structure, it's very important to note it down. Here also you can see that it is forming a dimer. What is dimer? It's simple. When you are combining two units of AlCl3 together, you get a dimer. Now why it is doing so? To remove its hypovalency or the deficiency of electron. Is it clear? Moving on to the next. What about its vapor density? So, just like boron fluoride, the aluminum is electron deficient, so it wants its 8 electrons to be completed, and that is the reason we are seeing the dimer structure of the aluminum. What will be the formula of this dimer? It will be Al2H6, Al2Cl6. Next, since AlCl3 is electron deficient, so it can act as a Lewis acid also. Therefore, it can react with ammonia, which has a lone pair present in it. Okay, so this is your reaction. And if I talk about the formation of HCl, then this is formed due to the reaction with heat. Okay, so if you heat your aluminum chloride, then it releases HCl, and this is your reaction. Al2Cl6 is reacting with your water to form AlOH whole thrice and AHCl. Got it? Now this is a simple reaction where your acid is reacting with a base, and hence it is accepting the OH minus from the H2O to form AlOH whole thrice. Then next, as a result of this, it releases 6 molecules of HCl. Again, the next reaction in which your Al2Cl6 is reacting with 12 molecules of H2O due to its deficiency in the electron and forming 2 AlCl3.6H2O. Remember, in case of your normal AlCl3, you can see that it is present in the dimeric form. But as soon as you dissolve it in water, it is present in a monomeric form. What is the reason behind it? Because as soon as you dissolve in water, its electron deficiency is being covered to some extent due to the lone pairs that are coming directly from the water. Okay. Next, if I talk about the reaction with ammonia, then it gives us the additional product, an addition product, and this is known as your adduct. We have talked about this in the boron part also. So where your boron is electron deficient, if you treat your boron with BH3 with the NH3, it will result in an adduct. Similarly, your AlCl3 is formed as a result of this adduct formation. Initially, your Al2Cl6 was formed due to electron deficiency. Then next, if you react it with the ammonia, then this electron deficiency is been removed by the NH3, and hence we see a AlCl3 here. Continuing with this aluminum chloride, if I do a reaction with NaOH, then it forms sodium meta-aluminate. This is the reaction, AlCl3 plus 3 NaOH giving us AlOH whole thrice plus 3 NaCl. Okay. Any doubt till this point? So if you have a doubt, you can just post it in the comment section. Anyone who has a doubt in this part? Okay. So this is your sodium meta-aluminate. When it is formed, first you treat your AlCl3 with sodium hydroxide. Then, since it is a Lewis acid, it will accept electron pairs from the OH minus and form the AlOH whole thrice. Next, if you just treat it further, it forms your sodium meta-aluminate, which is NaAlO2. Okay. So this anhydrous AlCl3, it is used in Friedel-Crafts reaction, where it acts as a Lewis acid and does the methation of your benzene. Okay, alkylation and acylation of your benzene. Next, it is also used in the manufacture of your drugs, dyes, and perfumes, and it is used in cracking of high boiling fractions of petroleum to form gasoline. So these are some uses of AlCl3 you can see here. Moving on to the next important compound of aluminium, which is alums. So if I talk about alum, imagine you mix two different salts. Okay, the first one is potassium sulfate and the second one is aluminium sulfate in water and let them crystallize. Then what will happen? Instead of separating back out, they stack together perfectly into a giant crystal like structure, and that is your double salt. The formula, the ratio is always fixed. One part of the monovalent cation, which can be K plus, Na plus, NH4 plus, and one part is the trivalent cation, which is Al3 plus, Cr3 plus, or Fe3 plus. Then there are 24 parts of the water molecule. This massive amount of water is what keeps the crystalline structure pure puffed, okay, puffed up and stable. You got my point? So this is the way your alums are formed. So here is a question. Aluminium, sir, aluminium does aluminium fused with NaOH gives sodium aluminate or sodium meta-aluminate? Okay. So anyone, if you want, you can give the answer for this question. So I will wait for you also to question the answer, those who are attending the class. Then I will tell you the answer. Anyone? So I'm giving you a time to just give me the answer here. So you're most welcome to give the answers of your friends as well. Okay. So basically, if I talk about this, so let me tell you. So both terms refers to the same final product in this context. In this context, but sodium meta-aluminate, which is NaAlO2, is the technically more accurate term for the anhydrous form product with the fused NaOH. So let me explain it. Why? So fused versus aqueous matter. This means that there is no water present, just like NaOH at high temperature. When aluminium reacts here, it forms dry oxide salt, which is sodium metaluminate. Okay. Now there is a confusion in the naming you would see in the JEE as well, but still it has the same meaning. You got my point? So both are referring to the same final product. So basically, what did I say? I said that it is technically more accurate name, which is your sodium metaluminate. Okay, so NaAlO2 or Na3AlO3. So I would suggest that if the option sodium metaluminate is given, then that would be the correct answer. Okay, if you are fusing the NaOH with aluminium, then your sodium metaluminate, which is NaAl2, so that would be more correct. The first option that you have given. Got it? So this you can write the reaction if you want. So two molecules of aluminium react with two molecules of sodium hydroxide in the fused part to give you NaAlO2, which is sodium metaluminate, plus the hydrogen gas. Got it? Okay. Next, as I said earlier, so you can have this uh, plus part which is coming from K plus or Na plus, and then we have this trivalent part which is coming from aluminium and your chromium, and then we have 24 molecules of water for potash alum. Is it clear to you? So you have a doubt still in this part? So these are some examples of alums that we are seeing. So we have potash alum, we have sodium alums, then we have ferric alums as well. Here the cationic part, means the plus one part, is coming from NH4, and your plus 3 part is coming from the iron. Now moving on to the next, what are alums? So they are isomorphous solids and they are soluble in hot water. Now their aqueous solution are acidic due to hydrolysis. On heating, alum swells up, leaving behind a porous mass called burnt alum. So if you have more doubts, you can just post it in the comment section. I will try my best to solve it. Okay. Okay. Now continuing further, as I said here, their alums are isomorphous solid. It means that these three formulas that you are seeing, only the formula is different, but their structure is same to each of them. Okay. Means their ratio is always 1 is to 24, and they have the same form in all the formulas. Got it? Now, why it is acidic in nature? What is the reason behind its acidic nature? So, acidic nature is coming from the 3 plus ions. That means your aluminium that is present here, or the iron or the chromium that can be present here. It is the reason that your given alums are showing a acidic nature. Now, next what we saw, the burning of alum. So, when you burn up the alum, what you get? You get a burnt thing known as burnt alum. What would be the first part? It would be removal of your water molecule, which is 24 parts. Got it? Next, this is the reaction that you can see. So first of all, this 24 molecules of water is removed, and then if you heat it further, it is decomposed. Now here both parts are occurring. I said that there are maximum two possibilities in almost all of the cases if you heat something. First is the removal of water, and second is the decomposition. Since if you heat it initially, first of all, at 200 degrees Celsius, 24 molecules of water will be removed. Then, heating it further will lead to decomposition. So here the possible decomposition is given here, K2SO4, and the Al2SO4 is decomposing into Al2O3 and 3SO3. Now you have seen a similar reaction, only the initial part was different. So basically, if you heat your uh, boron elements or the boron group oxides or any other salts, then it results quickly in the formation of their oxide like B2O3. Here also we are getting a Al2O3. Next, this thing is also used to purify water. You must have seen that alums are put in water such a, and they purify the water to some extent. So basically what do? They initiate or fastens the process of sedimentation. Means the larger molecules that are present there, they just coagulate together and falls down in the bottom of your container, and that leads to a extent of cleaning. Then they are also used in the cuts for stopping bleeding and as an antiseptic also. Okay, is it clear to you? So this alums part is also very important for all of you. Anyone who has a doubt till this part? Next we will do questions on it. So shall we move on to the question? Okay, so just wait for a while. I will just turn on the questions. Okay, so here is your first question. The catenation tendency of carbon, silicon, and germanium is in the order. So then first we have germanium, then we have silicon, then we have carbon. Now the bond energies of your carbon carbon, silicon silicon, and germanium germanium are respectively. Okay, so four options are given here, and this was asked in your JEE mains 2013. So what will be the correct answer? I am giving you some time to solve it. So it's a direct theoretical question. Just quickly give the answer in the comment section. So what will be the answer for this question? Anyone? What will be the answer for this question? So what do you mean by catenation property? It is basically the property by virtue of which it can form a longer chain. Okay. So if I consider your carbon and all, You certainly know that carbon is very much capable of forming long chains, and the direct application of that would be a protein. Okay, in the protein and the DNA, you have a long chain of made up of carbon, and that is only possible due to a unique property that is present in the carbon, which is catenation. Whereas this thing is there present in silicon, but it is not that much drastic, and in germanium and all, this thing is very less. Now you have to tell me that what is the bond energy order. So let me tell you the answer. The correct answer would be option number A. Yes, you are right. The correct answer would be option number A. Now, this thing that is given here, the catenation property, the extent of catenation property which is given here, itself is the result of stronger bond formation. So, if you are forming a longer bond and a stronger bond, then it needs the bonds to be very much stronger. Got it? Now, from that only, we can clearly say that the carbon bond is the strongest bond, then your silicon bond, and then your germanium bond. And that is the reason it is forming such a long chain in the given compound. So, what will be the correct order? It would be same as that of the catenation. So carbon carbon will be the largest one, then the silicon silicon, and then the germanium germanium. If you have looked upon on the options, you must have observed that there is only one option that justifies this order, which is option number A. So the correct option would be 348, 297, and 260. So you don't need to learn it up. Okay, it was a logical question. Higher is the catenation property, higher is the bond energy, and hence the bond energies are in the decreasing order from carbon onto germanium. Next question. You have to say that why your H3PO2 is a stronger reducing agent. So first one, low oxidation state of phosphorus. Second one, presence of two OH groups and one pH bond. Third one, presence of one OH group and two pH bonds. And last one, high electron gain enthalpy of phosphorus. So just tell me why it is a strong reducing agent. So there is a hint for you. Just try to draw the structure of this given H3PO2, and more is the number of pH bond. Okay, it's a simple law or simple trick to remember it. More is the number of pH bond, greater it is its reducing tendency, because pH bond are very much weaker as compared to the OH bond, and hence they can be easily released into the solution, and you know it very well from the classical definition of your reduction as well, that those substances which donates H minus or that adds H to any other element are strong reducing agent. So greater is the number of pH bond, greater is the tendency to reduce other elements or other species. So just try to count the number of pH bond, and that will give you your correct answer. Anyone, can you tell me the correct answer? So you would do a mistake of making this as the correct answer, which is low oxidation state of phosphorus. Okay, so this is not your correct answer. Anyone? Can you tell me what is the correct answer? Remember, you have to count the number of pH bond, and greater is the number of pH bond, stronger it is your given reducing agent. Okay, so there is a answer from you. Option number C. Yes, the correct option would be option number C. As I said earlier, that greater is the number of your pH bond, greater is its tendency to reduce other substances. So basically, your H3PO2 structure is having one OH group and two pH bonds. So that is the only possibility it can have for it to be a greater reducing agent. Next question. So if I talk about others, suppose if I talk about hydrophosphorus, or orthophosphorus or orthophosphoric, then there the number of pH bond is 2 for hydrophosphorus and 1 for orthophosphorus and 0 for orthophosphoric acid. So it is the weakest reducing agent as compared to all of this. Okay, it is not a reducing agent at the first place. Whereas the orthophosphorus is a strong reducing agent and your hydrophosphorus is a very strong reducing agent, which is H3PO2. Got it? I hope this makes sense. If you look at the formula also, it makes sense. So first is H3PO2, which is your or hypophosphorus. Then we have H3PO3, which is orthophosphorus. There is a introduction of one more oxygen, and that is keeping your hydrogen with it. Okay, because hydrogen prefers to make bond with the oxygen rather than phosphorus. And last is your orthophosphoric acid. Its formula is H3PO4. Okay, so the correct answer would be your two pH bonds. Next question. Nitrogen shows different oxidation states in the range 0 to +5, -3 to +5, -5 to +3, and -3 to +3. Now, this is a very easy question. Just tell me what will be the correct answer. For one thing we know for sure, that nitrogen is capable of forming 5 bonds. Okay. Now, just think about it. What are the compounds in which your nitrogen form 5 bonds, and whether it is forming it with the highly electronegative element or with the lower electronegative element, and then you can easily say that what is the lowest possible oxidation state or which is the highest possible oxidation state for it. So we have an answer here as option number B, -3 to +5. Anyone else? What is the correct answer for this question? Can you tell me a compound where it has a +5 oxidation state? Okay, we have one more answer. Option number B. Anyone else? Can you tell me a compound where its oxidation state is +5? Very simple example for it where it has a +5 oxidation state. Can you tell me that example? Anyone? And also tell it for -3. Just write it in the comment section. The name of the species where it shows -3 and +5 oxidation state. So let me tell it for you. The compound which shows a +5 oxidation state is your HNO3, okay, or your N2O5. In both cases, it forms a +5 oxidation state. The -3 oxidation state is very obvious. You take the case of ammonia, or you can take the case of your amines as well. In all of those compound, it has a -3 oxidation state. Therefore, the correct answer would be option number B. So, nitrogen can show all oxidation state varying from -3 to +5. So, for this, you have to just remember that what are the compounds which are possible for your nitrogen, and then you will easily get your answer because you know it very well how to calculate the oxidation state. Next question. A hydride of nitrogen which is acidic in nature. So we have 5 options here: NH3, N2H4, N2H3, and N3H. How it can act as an acid? By accepting electrons. Okay. One thing you know for sure, that NH3 is basic in nature. It donates a pair of electrons. So from this you can easily eliminate this option. Now you are left with 3 options: N2H4, N2H2, and N3H. Just try to draw the structure and then you will find it easier to answer this question. Just try to draw the structure and you will easily know that which one is acidic in nature? Let me give you one more hint. Here, one compound has a name similar to acid. Like we have the boric acid. Here also one compound has a name that has acid in its name itself. Okay. I hope this much hint is very much for you. Just try to draw the structure, or else you can remember if you want. Anyone who got the answer for this question? So I am seeing answer is option number D. Anyone else? What will be the correct answer for this question? Okay. So I am moving with this option number D. Yes, the correct option would be option number D, and the name itself includes an acid in it. It is known as the hydrojoic acid. Here, N3H is acidic in nature and it can donate proton, right? And what is the resonating structure? As I said, just try to draw the structure. This is N3H. Here, the H plus can be donated because the negative sign is stabilized into the whole molecule. Got it? Next question. The compound that does not produce nitrogen by the thermal decomposition. So this was asked in 2018, and four options are given here: BN3, BaNH3, N3 whole twice, then NH4 whole twice Cr2O7, NH4NO2, and NH4 whole twice SO4. You have to tell that which compound cannot produce nitrogen gas by thermal decomposition. So what will be the answer for this question? So let me give a hint to you. So basically, you have to see that which one is a oxidizing anion. Okay. So to produce nitrogen gas from an ammonium salt, the anionic part of the salt must be a strong oxidizing agent capable of oxidizing the ammonium nitrogen to nitrogen gas. Just check the anions that are given here. So possibly your NH4 containing compound are only capable of releasing N2 gas, and N3 is also a one which produce N2 gas, and you have seen this kind of reaction is organic as well. N3, so this one is absolutely correct. So it produces the nitrogen gas, but you have to think between these three. Okay, so this was an exception. So I told you that this one produces your nitrogen gas. But what about these three? Think about these three. You have to only look upon the anionic part and see which one is not oxidizing enough. Anionic part are Cr2O7, NO2, and SO4. So what will be the answer? Remember one important point here from this question, that azides are always, no matter whatever with a cation, whenever you heat a azide, this N3 is known as azide. Whenever you heat a azide, you will release a nitrogen gas. Okay, because this azide is very less stable. It quickly decomposes to form the N2 gas. So the correct answer will be option number D, which is NH4 whole twice SO4. So this is the reaction at source. Now, if I talk about Cr2O7, then this Cr2O7 is a strong oxidizing agent. Got it? Therefore, it is capable of oxidizing the ammonium nitrogen, which is given here in the form of NH4 plus, to form the NO gas. Got it? And then it is further decomposed to form the N2. So you have to look upon the anionic part. Similarly, your NH4 NO2 is doing the same thing here, and your NH4 whole twice SO4 is not doing that same thing. So we have three options. So first is your nitride, sorry, your azide. So that always decomposes to form the nitrogen gas. And if I look upon these two options, which are Cr2O7, 2 minus and NO2 plus, so these two are strong oxidizing anion and they are capable of oxidizing this NH4 to N2. Whereas this SO4 is not strong oxidizing agent itself and hence cannot form the N2 gas. Got it? So this is the fourth reaction. Therefore, the correct option will be option number 2. It produces ammonia instead of nitrogen. Next question. Extra pure N2 can be obtained by heating. So again, this is related to production of N2. So four options are given here. NH3 with COO, NH4 with NO3, NH4 whole twice with Cr2O7 and BaN3 whole twice. So what will be the correct answer? So all of them can produce nitrogen. You have to look for that reaction that will not produce any gas apart from nitrogen. It will only produce solids. Okay, so that is the meaning of extra pure N2. Got it? So we have just seen a reaction. If you have seen that reaction properly, we have our answer from that part only. You have to just see that where we are getting only nitrogen in the product and not any other gas. The byproducts are in the solid state. Can you tell me what will the answer? So what will be the answer for this question? We have just seen the reactions for regarding these two. You have to look upon that option that releases pure nitrogen. Okay, means it can only have a solid as a byproduct and not a gas, or else it would be a impure nitrogen. Okay, so we have answer is option number C, but it would be BaN3 whole twice. So barium nitrate, if you treat, it gives us barium solid and the nitrogen gas. Therefore, here we are getting only nitrogen as the gas and no other gases are present in the mixture. Therefore, this process can be used to obtain extra pure N2. Got it? Which is coming from your azide. Moving on to the next question. The number of sigma bonds which are present in P4O10. Options are C, A16, A6, B16, C20 and D7. So what will be the answer for this question? Again, for this you have to draw the structure. You will easily get your answer from there. Okay, let me give you the correct answer. The correct answer will be B, which is 16. So if you just draw the structure of the P4O10, then you will see that there are 16 sigma bonds and 4 pi bonds. Okay, here is the structure. So this 4 phosphorus which are present here, they are forming a double bond with the oxygen, and these 4 phosphorus are forming the 4 pi bonds, whereas the other phosphorus and oxygen bonds are sigma in nature. Got it? So it's very simple, I guess. Moving on to the next question. If you know the structure, you can easily draw it. So next one is pH 3, the hydride of phosphorus is, first of all, option number A, metallic, B, ionic, C, non-metallic, and D, covalent in nature. So this one is a tricky question. So there may be a confusion between non-metallic and covalent. We know it for sure that it is not metallic and not ionic. You have to see that whether it is non-metallic or covalent. Remember, something to be a metal or to be a non-metal, it has to be an element. Okay, you can't tell a compound to be a metal or a compound to be a non-metal. I hope this much hint is enough for you. So what will be the answer for this question? What will be the nature of your hydride of phosphorus? Means your pH 3. So the correct answer would be covalent. Why it is? What is the reason behind it? Because you can't tell a given compound to be a metal or non-metal. It can be only an element. This categorization is only possible for an given element. Possibly, and hopefully it is not ionic, because both of them are non-metal in nature. Therefore, the only option that you are left with is the covalent hydride. Next question, you have to tell that when concentrated HNO3 is heated with P2O5, okay, then what would it form? So four options are given here. You have N2O, then you have NO, then you have NO2, and then you have N2O5. So what will be the correct answer for this? Just post it in the comment section. So you have to basically do a reaction between HNO3 and P2O5. Just post your answer in the comment section. Okay, so if you are not getting the answer, let me give you a hint. So P2O5 here will act as a dehydrating agent. Okay, so it is a strong dehydrating agent. So you can also call it as P4O10 or P2O5. So they act as a strong dehydrating agent, and you are reacting an acid with it. What you have to do is to simply remove the water from here. Now you have to think of possibility. If you remove it from one molecule of your HNO3, what you will get, whether it is stable or not, or if it is not stable, then take two molecules of HNO3 and then remove water from it. Okay, from there you will get your answer. So we have answer here as option number D, which is N2O5. So moving on to the correct answer, it will be option number D. Very good. Why N2O5? Because if you heat one molecule of HNO3, you will get water removed, and that will not form a stable molecule. Okay, so just try this out with two molecules, then you will clearly see that you are getting N2O5. Next question. Okay, so this was all for today's lecture. Uh, so just wait for a while. Let me open the DPPs for you. So we will go through the DPPs as well. So I am seeing a very less member of contestant in the DPPs. I will request you all to please do the DPPs as well. So let me open the DPPs for you. So those who have still not registered to our website, so let me just help you with that. So how do you just register onto our website? So just open our websites and you can clearly see that there is a banner for our, of our going 40 days crash course. Click here, then you can register it from here. Okay, so once you register it, then you can log in using the old users, or if you are not registered still, you can just go to the Google, and from there, means using your email ID, you can also register here. Now once you are registered to it, just enter the username and your password. As soon as you do it, you will be taken to our tab which includes all the courses that we are dealing with. So this is your all course type, where we have all courses regarding the detailed part of class 11th and 12th as well. Then this is your crash course, and here we have the recorded lectures. Okay, so if this is the view lecture part, we can see the previous lecture. Then we have a review test for each of them, and then we have a all India mock test also. Now from here, you can see that we have our video lectures posted here. So just click here for chemistry, just click here on chemistry, and from here you can attempt the DPPs. See, we have the DPPs here as well as the notes present. So let us open a DPP from our previous part that we have already covered. Let's do it for the chemical kinetics. Okay, so we have covered this chemical kinetics. First, you have to do this checkbox, clear this checkbox, and proceed here. So you will see the same appearance of the website on your JEE exams as well. So this will give you a hint, or this will give you a practice of what kind of question attempting scenario will be there. Okay, so in this way you will be given your question. So you will have questions from 1 to 10. In JEE exam you will be having 75 questions, 25 from each. Now this is a DPP, so we have included only 10 questions. Now for this 10 questions we are being given 20 minutes. Okay, and you can just solve it here. So suppose you have the first question. Suppose the rate of a reaction triples with the temperature change by 15 degrees Celsius from 298 to 330. Then what will be its activation energy? So what is given here? We are given with the rate of reaction, which is tripling. Now if this is tripling, that means your rate constant is also tripling. Got it? So what you will do, you will just plug it into the Arrhenius equation, which is log K2 by K1. Okay, then you will put one as K and the second one as 3K. You will apply the temperature also, 298 and 313 Kelvin, and from there you can calculate your EA. Got it? Suppose we got the answer as 40 kilojoule per mole. So I am not calculating it. So this okay. So for 36 kilojoule per mole. So just click it here and save and next. Okay. Next, this is your second question. In this, you have to you are given that two first order reactions proceed at 25 degrees Celsius temperature at the same rate. Rates are same, but the temperature coefficient of the first one is 2 at the second, and the second one is 3. You have to find the ratio of the rates of this reaction. Now suppose you don't know the answer. You have calculated it, but you are in disappointment. You have calculated suppose 7. Okay, then what you can do? You can just click here, save and mark for review. So this will create a violet color here along with a green dot, that is indicating that you have corrected the answer but you are not sure about it. Got it? Next one. Suppose this is the third question and you don't know anything about this question. In that case, what you will do? You will only click here, mark for review and next. Okay, so these are the meanings of both things. Further, if you complete your test, just click submit here and click yes here. So that will lead to your answer, your number part. You can see that so this was a random choice, so this is absolutely incorrect. And here we have the explanation also. In the bottom part, you can see that we have clear explanation for each and every question. Okay. So this was all for today's lecture. Thank you for joining the session, and please attempt the DPPs as much as you can, and this will help you to do well in your exams, because DPPs are important. Okay. Simply learning the theory will not help you. So please do the DPPs along with it.
Hello everyone. So in today's lecture, we will cover differential equation. Okay. Okay. So from this chapter, the chapter differential equation, on the examination JEE, weightage is 4.26%, and on an average, one question asked each year. In the year 2024, two questions came from the chapter differential equation based on particular solution that is can be solved by variable separable and substitution method. In the year 2023, one question from the topic homogeneous differential equation that can be solved by simple substitution y is equal to wx. In the year 2022, two question from the topic linear differential equation, its particular solution. In year 2021, one question of average level from linear differential equation based on integrating factor. In the year 2020, one question from the chapter differential equation based on variable separable method. In the year 2019, two question of easy type based on linear differential equation, how we calculate integrating factor and variable separable method to solve a differential equation. In 18, again one question came from the topic variable separable method of average level. Okay. Okay. So in today's class, we will first explain what is differential equation. Okay. Then order and degree of differential equation. Solution of differential equation, that if we have a differential equation, then what are the different methods to solve that differential equation. One type of solution is general solution for a differential equation, and another is particular solution. Then solution of differential equation of the first order and first degree. So we see the different method to solve a differential equation of first order and first degree. Okay. Like differential equation with variable separable, then reducible to variable separable form. So there is a differential equation that is not in a variable separable form, but how we can reduce that differential equation into a variable separable form so that we can apply the method of variable separable to solve that differential equation. Then homogeneous differential equation. At first, we will discuss what is homogeneous equation. Then, what is the form of homogeneous differential equation and how to find its solution. What is the method? What is the procedure? After that, an important differential equation, that is linear differential equation, its form, and then Bernoulli differential equation. It is another form of differential equation that can be reduced to linear differential equation. Okay. And finally, we will see inspection method to solve a differential equation. Okay. So let's start. First, what is differential equation? Okay. So an equation involving independent variable, so an equation in which there is an independent variable, a dependent variable, and the derivative of dependent variable with respect to the independent variable is called a differential equation. Okay. So what is the definition of differential equation? Understand again, there is an equation and there is an independent variable, there is a dependent variable, and also the derivative of dependent variable with respect to the independent variable. Then such kind of equation is called differential equation. So for example, delta z by delta x plus delta z by delta y is equal to x square plus y square. That is partial derivative of z with respect to x plus partial derivative of z with respect to y is equal to x square plus y square. So here z is dependent variable, depend upon variable x and y. So x and y are independent variable. Okay, and also there are derivative, there is a partial derivative have been used in this equation, that is partial derivative of z with respect to x and partial derivative of z with respect to y. Okay, so this is the equation involving independent variable, that is x and y, dependent variable, that is z, and derivative of dependent variable with respect to independent variables. So these type of equation is called differential equation. Specifically, this equation is partial differential equation because here the number of independent variable is more than one. There is two independent variable, that is x and y. Z is dependent upon x and y. One independent variable, one independent variable, and two independent variable. So this type of differential equation is called partial differential equation. Okay. And if a differential equation which has only one independent variable, then it is called ordinary differential equation. Okay. Now in this example, dy by dx plus y is equal to e the power x. So here y is your dependent variable and depend upon the variable x. So y is your dependent variable and x is your independent variable. Okay. So and also in this equation there is a derivative dy by dx. So one derivative dy by dx, derivative of dependent variable y with respect to independent variable plus y is equal to ex. So this is an example of differential equation, and specifically this is an example of ordinary differential equation. Why? Because there is only one independent variable, that is x. Okay, clear? Any doubt? Okay. So now we'll discuss important concept of differential equation, that is order and degree of differential equation. These are very important terms. So the order of a differential equation is the order of the highest derivative occurring in the differential equation. So if you are given a differential equation and asked what is the order, then we need to see which is the highest order derivative in that equation, and whatever the highest order derivative is, that will be the order of the differential equation. For example, there is second order derivative in this equation, that is d2y by dx2 plus dy by dx plus y is equal to 0. So which was the highest derivative in this equation? That is d2y by dx2, highest derivative, and that is second derivative. So order of this differential equation is 2. Okay, so we can easily calculate the order of the differential equation. We just need to see what is the highest derivative term present in the differential equation, and that is your order. Okay, order of that highest derivative term is order of the differential equation. Okay, so order of a differential equation always depend on the derivative, that is of the highest order. As in this equation, the largest derivative is d2y by dx2, which is the second derivative. So the order of this differential equation is 2. Okay. Now, what is degree? So to calculate degree is more complicated than calculating the order. We can easily calculate the order, but we can't calculate the degree easily than like order. Sometimes degree can be exist and cannot be exist. Okay. So the degree of a differential equation is the degree of the highest order derivative. Okay. So if there is a differential equation, then the highest power of highest order derivative present in the differential equation is the degree of the differential equation. Okay. But when the degree differential coefficient are made free from radicals and fraction. Okay. So to define degree, the differential equation must, the differential coefficient are must free from radical and fraction. Okay. So it can be also that if your given differential equation is polynomial with derivative, then we can define degree. Like if you have an example like d2y by dx2 whole power 2 plus sine dy by dx is equal to 0. So this is not a polynomial with derivative because there is a term involving sine dy by dx. Okay. But if there is equation like d2y by dx2 plus dy by dx plus sine y is equal to 0, then we can define degree because now this equation is a polynomial with derivative, not polynomial in y, because there is a term like sine y. But we have to check is the given differential equation is polynomial in derivative like y dash, y double dash, whatever the order present in that derivative. Okay. Then we can define the degree of the differential equation. Clear? Any doubt? So in this example, d2y by dx2, that is differentiation of y with respect to x 2 time. So order is 2 power 3 plus dy by dx is equal to x. So highest derivative present in this equation is d2y by dx2. So order of this differential equation is 2. Now what about degree? So for degree, at first we have to check is this given equation is the differential coefficient are made free from radicals and fraction, and is this given differential equation are polynomial in derivative. So this given differential equation is polynomial in derivative d2y by dx2 and dy by dx. So we can define the degree of this differential equation, and that is the highest power of the highest order derivative present in the given differential equation. Highest order derivative present is d2y by dx2, and the highest order of that highest order derivative present in this equation is 3. So degree of this differential equation is 3 and order is 2. Clear? So order for a differential equation always exists, but degree can and cannot be. Okay. Clear? Okay. Good. Now, so now we'll discuss solution of differential equation. So if you have any differential equation, then how will you solve it or what are its method? So at first we discuss what are the solution of the differential equation. Okay. So solution of the differential equation is a relation between the dependent and independent variable of the equation not containing the derivative but satisfying the given differential equation. Okay. So a solution is a function. So if we have a differential equation, so solution for that differential equation is a function, and that is a relation between the dependent and independent variable. But that does not contain derivative. That equation does not contain the derivative, but satisfy the given differential equation. So if we have an differential equation like dy by dx is equal to fxy, so if there is a function like phi, so if we substitute the phi in place of y and it satisfied that differential equation, then that function phi is a solution for that differential equation. Okay. So the solution of any differential equation is such that it contains a dependent variable, an independent variable, but no derivative. Okay. And if that relation also satisfies the given differential equation, then we say that function, that relation is solution of the differential equation. Okay. So now we'll talk about the general solution of a differential equation. So a general solution of a differential equation is a relation between the variable not involving the derivative which contain the same number of arbitrary constant as the order of the differential equation. So if a solution have the same number of arbitrary constant as the order of the differential equation. For example, if the order of a differential equation is 4 and in the solution contains also the 4 arbitrary constant, 4 independent arbitrary constant, then that solution is called the general solution for the differential equation, for the differential equation. Okay. Now what is particular solution? So if we substitute the value of arbitrary constant with a particular value, then we get a particular solution. So particular solution of a differential equation is obtained from the general solution. We have a general solution. Then if you assign the particular value to arbitrary constant, then we get a particular solution. Okay. What is general solution? General solution involving arbitrary constant, and the number of arbitrary constant is equal to the order of the given differential equation, and we get a fixed value for that arbitrary constant, a particular values for that, for all arbitrary constant, then we get a particular solution for the given differential equation. Okay. Now, so now we'll discuss solution of differential equation of the first order and first degree. So if we have any differential equation and the order of the differential equation is 1, that is highest derivative or derivative present on that differential equation is dy by dx, and also the it is of the first degree, that is the power of the highest order derivative present on the given differential equation, that is dy by dx is 1, that is of the first degree. Then what are the different methods to solve this type of differential equation? Okay, so let's discuss. First one is variable separable method. First method to solve differential equation of first order and first degree is variable separable method. Okay. What is this method? If we have a differential equation like dy by dx is equal to fxy, and if we can write that fxy as, like if we take it capital Fxy, the function with x and y, if you write that fxy as gx into hy, okay, where gx is a function of x and hy is function of y, okay, so we get dy by dx is equal to gx into hy. So here we can separate the variable. We write the term involving y with dy and the term involving with x with tx, so that we can write 1 by hy dy is equal to fx dx. Okay, so that 1 by hy is gy, so we get gy dy is equal to fx dx. So if that function that is dy by dx if is equal to fxy can be written the product of two functions, where the one function is of x and one function is of y, then we can use the variable separable method. What we do, we just write the term, the function with y with dy and function with x with dx, and we separate the variable as gy dy is equal to fx dx. So if we integrate this, gy by di is equal to fx dx, we get the solution of the differential equation. Okay. So whatever the differential equation given, if you can separate the variable as in this form, that you can write all the term involving y with dy and all the term involving x with dx, then we can easily find the solution of the differential equation. We just need to integrate this, okay, to find the solution. Clear? Now we'll talk about reducible to variable separable form. Okay, so we are given a differential equation, that is dy by dx is equal to f ax plus by plus c. Now this is not this is not in the form of variable separable form, but can we reduce it to variable separable form or not? So by using substitution, we reduce it to a variable separable form. Okay, and what is the substitution? We take the ax plus by plus c is equal to z. Now z is function of x and y is function of x, because there in the question, in the form, there is present dy by dx. So y is a dependent variable and it depend upon x. Okay, so y is dependent upon x and z is dependent upon x and y. So we just take ax plus by plus c is equal to z. Okay, now differentiate this with respect to x. We get a plus differentiation of x with respect to x, that is 1, plus b differentiation of y with respect to x, that is b dy by dx, is equal to differentiation of z with respect to x, that is dz, is equal to dx. Okay, so we have to find the value of dy by dx to substitute in the form dy by dx is equal to f ax plus by plus c. So we just do a manipulation, we get dz by dx minus a 1 by b is equal to fz. We just substitute the value of dy by dx in terms of z into the form dy by dx is equal to f x plus by plus c. Then we get dz by dx is equal to a plus b f z. Okay, we substitute dy by dx is equal to dz by dx minus a 1 by b in place of dy by dx, and for f ax plus by plus c we write fz. And when this we simplify this, we get dz by dx is equal to a plus b fz. And now this form is in the form of variable separable method, variable separable form, where we can separate the term involving z with z and the term involving x with x. So we can write this as dz by a plus b fz is equal to dx. Okay, and when we apply the variable separable method, we just need to integrate this to find the solution of this differential equation. So by a simple substitution, ax plus by plus c is equal to z, we reduce this form into a variable separable form. Clear? Everyone understood? Any doubt? Please confirm yes sir, no sir, anything? Okay. Now we talk about homogeneous differential equation. So, to understand homogeneous differential equation, at first, what is homogeneous function? So, if there is a function fxy, then this function fxy is said to be a homogeneous function of degree n if we replace your x and y by lambda x and lambda y. Then if you can write this as lambda the power n fxy for some non-zero constant lambda, then your function fxy is called homogeneous function of degree n. Okay, so how we can check a function is homogeneous function or not? We just replace that x and y by lambda x and lambda y. We just substitute lambda x and lambda y in place of x and y, and if we get the function in this way, that is the lambda n is, we get lambda the power n into fxy, then this function fxy is called homogeneous function of degree n, and lambda is none, it is a non-zero constant. Okay, so what is homogeneous differential equation? So if we have two homogeneous function of same degree, first one is fxy and the second one is gxy, both are the homogeneous function of same degree, that is n is equal to same for both function, then a differential equation that is expressible in the form of dy by dx is equal to fxy by gxy, then this form is called homogeneous differential equation. So if you have a differential equation of the form like dy by dx is equal to fxy by gxy, where both fxy and gxy are homogeneous function of same degree, it means when we replace the x and y by lambda x and lambda y, we get lambda the power n fxy and lambda the power n gxy. That is n is same, that is order the degree for the both homogeneous function are same, then this form is called homogeneous differential equation. Okay. And what is the method to solve this homogeneous differential equation? So if we have a differential equation of the type dy by dx is equal to fxy by gxy, where fxy and gxy both are the homogeneous function of same degree, so we can also write it in this way, h another function h y by x. Okay. So if you have a differential equation of the type dy by dx is equal to h y by x. Okay. So this is your homogeneous differential equation. Now to solve this, we substitute, we put y is equal to vx, that is y by x is equal to v, and by using this simple substitution we can solve this differential equation, because when we take y is equal to vx, we differentiate it with respect to x, we differentiate, we get dy by dx is equal to v differentiation of x, that is 1, v plus x into differentiation of v with respect to x, that is dv by dx. So we get v plus x into dv by dx, and when we substitute in place of dy by dx, that is v plus x dv by dx is equal to h v, then that form is in the form of variable separable form, where we can apply the variable separable method to solve this homogeneous differential equation. So by a simple substitution y is equal to vx, it transforms to a variable separable form. Okay. And another form of homogeneous differential equation is dx by dy is equal to fxy by gxy, where h is equal to h x by y. So if your given differential equation is of the form dx by dy is equal to hx by y, so for here we use a substitution x is equal to vy. Okay, so we take x is equal to vy, differentiate it with respect to y, we get dx by dy is equal to v plus y dv by dy. Okay, and then we take this value of dx by dy and substitute into the given differential equation, then we can easily solve that differential equation by variable separable method. Okay, so that's your homogeneous differential equation. Clear? Varsha, clear? Okay. Now another form is linear differential equation. So a differential equation of the form dy by dx plus py is equal to q, where p and q are the function of x or constant, is called linear differential equation. Okay, so this is the exact form of linear differential equation, and that form is dy by dx plus py is equal to q, where p and q are the constant or function of x only. Then this is called linear differential equation. Okay, so to solve such an equation, at first we have to find the integrating factor. And how we can calculate integrating factor? Integrating factor is given by e the power integral of p dx. So when we have an integrating factor, we calculate by this formula, then the solution of this differential equation given by y into integrating factor is equal to integration of q into integrating factor dx plus c. Okay. So in other words, by multiplying the integrating factor, we make the equation integrable. And that's how we can find the solution of linear differential equation. Okay, the simple formula y into integrating factor is equal to integration of q into integrating factor dx plus c, where integrating factor is calculated by e the power integration of p dx, and the form of linear differential equation is dy by dx plus py is equal to q, where p and q are either constant or function of x only. Okay, there is more one another form of this linear differential equation is dx by dy plus rx is equal to s. Okay, so if your given linear differential equation is of the form dx by dy plus rx is equal to s, now here r and s are either constants and function of y only, then the solution of this differential equation is given by the formula x into integrating factor is equal to integration of s into integrating factor dy plus c, where this integrating factor can be calculated by e the power integration of r dy. So these are the two different form of linear differential equation. Clear? Next, now what is Bernoulli differential equation? This form can be reduced to a linear form. Okay, so Bernoulli differential equation is a non-linear first order ordinary differential equation. The form is dy by dx plus py is equal to q into y the power n. Okay, so this is your non-linear differential equation because there is a term y the power n on the right side. To solve this equation, what we do, we multiply both sides by y the power minus n, we get y the power minus n dy by dx plus p into y the power minus n plus 1 is equal to q. Okay, then we take a substitution, we put y the power minus n plus 1 as z. Okay, and then when we take y the power minus n plus 1 is equal to z, we differentiate this with respect to x. So when we differentiate this, we get minus n plus 1 y the power minus n dy by dx is equal to dz by dx. Okay, then now we substitute the value of y the power minus n dy by dx from this equation to y the power minus n dy by dx plus p into y the power minus n plus 1 is equal to q. And when we substitute the value, that value is y the power minus n dy by dx is equal to 1 by minus n plus 1 dz by dx. So when we substitute this and simplify this, we get dz by dx plus 1 minus n pz is equal to 1 minus n q. Okay, and this is the form of linear differential equation in Z. So by using a simple substitution y the power minus n plus 1 is equal to z, we reduce the given Bernoulli differential equation into a linear differential equation. And we already discussed how we can calculate the solution of a linear differential equation. So when we apply that formula, the solution for this given differential equation is z into e the power integration of 1 minus n p dx, that is integrating factor, is equal to integration of 1 minus n into q into e the power integration of 1 minus n p dx plus c. Okay, so that's how we can reduce a Bernoulli differential equation into a linear form. Clear? Now, now we'll talk about the inspection method. So, if you can write the differential equation in the form f f1xy d f1xy plus phi f2xy d f2xy plus dot dot is equal to 0, then each term can be easily integrated separately, and we can also consider each term separately for this. Okay, we have several results that we can directly apply when we solve a given differential equation by inspection method. Okay, that is, first one is dx plus 1 y is equal to dx plus minus dy. That is, when we integrate dx plus minus 1 dy, it can be written as dx plus minus y. So integration of dx plus minus dy is x plus minus y. So that's how we can use this formula to solve our differential equation. Okay, these are the inspection method. Second result is dxy is equal to x dy plus y dx. When two functions multiplied like x into y, then their differential is not the differential of a simple product. We call this the product rule. That is, dxy is equal to x dy plus y dx. Third result, dx by y is equal to y dx minus x dy by y square. How we can use this? If we have a if you want to solve a differential equation and there is a term like y dx minus x dy by y square, then we can write this term as dx by y. And when we integrate this to find the solution of differential equation, so integration of y dx minus x dy by y square is equal to integration of dxy, and from here you get x by y. Okay, so that's how we can use this formula to solve differential equation. Fourth result, d tan inverse x by y is equal to y dx minus x dy by x square plus y square. Fifth, d log xy is equal to x dy plus y dx by xy. Clear? D log x by y is equal to y dx minus x dy by xy. Next result, d 1 by 2 log x square plus y square is equal to x dx plus y dy by x square plus y square. Okay, so if you remember all this result, then if you apply the inspection method on a differential equation on that form, then we can easily find out the solution of the differential equation. Okay, we practice some question based on this, then you understand how we can use this result to solve a differential equation. Next is d minus 1 by xy is equal to x dy plus y dx by x square y square. D of ex by y is equal to y into e to the power x dx minus e to the power x dy by y square. Next, d of root under x square plus y square is equal to x dx plus y dy by root under x square plus y square. And then d 1 by 2 log x plus y by x minus y is equal to x dy minus y dx by x square minus y square. Okay. Just wait for a moment. Okay, so now we'll practice some question based on differential equation. Okay, so first question. The order of the differential equation whose general solution is given by y is equal to c1 e the power 2x plus c2 plus c3 e the power x plus c4 sine x plus c5 is. So we have to find the order of the differential equation. Okay, and the general solution is given. So what is the relation between order and the general solution? Specifically, relation between order and number of arbitrary constant on a general solution. Okay, so just recall and try to solve this question. What is the relation between order and number of arbitrary constant of a general solution? Anyone? Order of the differential equation is equal to number of independent arbitrary constant in a general solution. Okay, clear? So, which option is correct? No idea? Okay, let's try. So, correct answer is option B, that is 4. Let's solve. Given we have general solution of the differential equation, and that is y is equal to c1 e the power 2x plus c2 plus c3 into e the power x plus c4 sine x plus c5. अब in total there are 5 arbitrary constant, but order is equal to number of independent arbitrary constant. Okay, so we can write in this way: y is equal to c1 into e the power c2 into e the power 2x, because we know that if e the power x plus y, then we can write it as e the power x into e the power y, plus c3 into e the power x plus c4, and now is the formula of sine a plus b, that is sine a into cos b plus sine b into cos a. So we get sine x into cos 5 plus sine cos x into sine 5 sine c5. Okay, so from here we can write c1 and ec2 both are constant. So for both constant we take one constant, that is a. So a is equal to c1 into e the power c2. So a into e the power 2x plus c3 into e the power x plus c4 and cos c5 both are constant. So for that we take b sin x in similar way plus b cos x. So now Here a is equal to c1 into e the power c2, b is equal to c4 cos c5, and d is equal to c4 sin c5. So this equation consists four arbitrary constants. So the order of this given differential equation is 4. Clear? So order of the given differential equation is equal to number of independent arbitrary constant present on the general solution of that differential equation. Clear? Okay. Next question. The degree of the differential equation. Now we have to calculate the degree. Differential equation is d2y by dx2 plus 3 into dy by dx whole square is equal to x square log d2y by dx2 is options 1, 2, 3 and none of this. Okay. So in this question we have to calculate degree. So what is degree? Degree is the highest power of the highest order derivative present in the differential equation. But to define degree, the given differential equation must be polynomial in derivative. Okay. Then what do you think? Which option is correct? It 1, 2, 3 and none of this. Take your time. Okay. None of this. Anyone else? Okay, let's see. So correct answer is D. None of this. Okay, very good. So degree of a differential equation is defined only if that equation is polynomial in derivative. But as in this differential equation, the given differential equation is d2y by dx2 plus 3 dy by dx whole square is equal to x square log d2y by dx2. And due to the presence of this, the RHS side is log d2y by dx2. And this means there is equation involving a transcendental function of the highest derivative. So this is not a polynomial in the term of d2y by dx2. So we cannot define degree for this differential equation due to presence of log d2y by dx2. So correct answer is option D, none of this. Clear? Okay. Next question. Order and degree of the differential equation representing the family of curve y square is equal to 2c x plus root c, where c is a positive parameter, are respectively equal to. So we are given a family of curve, that is y square is equal to 2c into x plus root c, and asked for what is the order and degree of the differential equation. So at first we have to find the differential equation for this family of curve. Okay, so first task is calculate its differential equation for this family of curve, and when we have the differential equation for this family of curve, then we calculate order and degree according to the definition of order and degree. Okay, so try this question. At first find the differential equation for this family of curve, that is y square is equal to 2c into x plus root c. Okay, Varsha, are you trying? Okay, let's solve together. So correct answer is option A, that is 1 and 3. So order of the differential equation is 1 and degree is 3. So given family of curve is y square is equal to 2c x plus root c. At first we have to find the differential equation for this family of curve. So when you differentiate this with respect to x, we get 2y dy by dx is equal to 2c. Differentiation of x is 1 and differentiation of root c, that is constant, is 0. So we get 2y dy by dx is equal to 2c. From here we get c is equal to y dy by dx. So now on putting in equation 1, we just substitute the value of c in equation 1. We get y square is equal to 2xy dy by dx, that is 2cx, value of c is y dy by dx, so we get 2xy dy by dx, plus c into root c, that is c the power 1 by 2 plus 1, that is c the power 3 by 2. So when we substitute the value of c, so we get y 2y whole power 3 by 2 into dy by dx 3 by 2. Okay. Now to find the value of order and degree, so what is the order? This is a differential equation for the family of curve y square is equal to 2c x plus root c. It is clear that the highest order derivative present in the given differential equation is dy by dx. So order is clear 1. But to find the degree of this differential equation, we have to remove this fraction power. So if we can remove this, try to remove, we write it as y square minus 2xy dy by dx is equal to 2y the power 3 by 2 dy by dx whole power 3 by 2, and then take a square both side. We get 4y cube dy by dx whole cube is equal to y square minus 2xy dy by dx whole square. Okay, and now this is your differential equation free from this fraction power. So now we can calculate its degree as well as order. So order is clear 1, the highest order derivative present in this given differential equation dy by dx. So order is 1. What about degree? So degree is the highest power of highest order derivative present on the given differential equation, that is dy by dx, and its highest power is 3. So degree of this differential equation is 3. Clear? Any doubt? Next question. The differential equation of all circle in the first quadrant which touch the coordinate axis is of order. So at first we have the given differential equation is of the circle in the first quadrant, and we only need to calculate the order. We don't need to calculate its degree. So at first, what is the equation of circle in the first quadrant which touch the coordinate axis? Okay, so first write the equation for this and then calculate its order. Options are 1, 2, 3 and D, none of this. You can calculate its differential equation of this all circle and then calculate its order, and there is one other method that you can also use to find its order. Okay, and that is easier than to calculate differential equation. We can relate order of a differential equation with number of arbitrary constant. To try that concept. Anyone? So correct answer is option A, that is 1. So the equation of family of circle that touch the both x's and that is in the first quadrant is x minus a whole square plus y minus a whole square is equal to a square, and where a is a parameter. So as there is only one parameter, therefore order of the differential equation is also 1. Clear? So to find the order, we don't even need to find the differential equation for this family. Okay? As because there is only one parameter, so the order of the differential equation is also 1. But to calculate its degree, we have to find the differential equation. Okay? But in the question, there is only asked for what is the order of the differential equation of this family of curve. Next question. The differential equation of the family of curve V is equal to A by R plus B, where A and B are arbitrary constant is. So, we are given a family of curve that is V is equal to A by R plus B, and where A and B are arbitrary constant, and we have to find the differential equation for this family of curve. Options are d2v by dr2 plus 1 by r dv by dr is equal to 0. Option B, d2v by dr2 minus 2 by r dv by dr is equal to 0. Option C, d2v by dr2 plus 2 by r dv by dr is equal to 0. And option D, none of these. Okay, so try this. There are two arbitrary constants, a and b. So what is the order of this differential equation? Just think on that way and then differentiate this family of curve and try to find the differential equation. In C, that is d2v by dr2 plus 2 by r dv by dr is equal to 0. Let's check. So correct answer is option C, that is d2v by dr2 plus 2 by r dv by dr is equal to 0. Varsha, very good. Okay, so let's verify. We have family of curve that is v is equal to a by r plus b, where a and b are parameter. So to find its differential equation, we differentiating this with respect to t, we get dv by dr is equal to minus a by r square, and differentiation of b is 0. So we get dv by dr is equal to minus a by r square. Okay. Now, as there is two arbitrary constant, so order of the differential equation is 2. So we again differentiate this. Then we get d2y by dr2 is equal to 2a by r cube. Our main goal is we want to remove this arbitrary constant. So by using 1 and 2, we can remove this a. So now on substituting the value of a from 1 in equation 2, we get d2v by dr2 is equal to 2r cube into value of a from 1 is minus r square d by dr, that is equal to minus 2 by r d by dr. So we get d2v by dr2 plus 2 by r d by dr is equal to 0. Okay, so this is your differential equation for family of curve v is equal to a by r plus b. Clear? Now, next question. The solution of the differential equation x dx plus y dy plus x dy minus y dx by x square plus y square is equal to 0 is. Okay, so this is the differential equation. We have to find the solution for this differential equation. Okay, so options are y is equal to x 10 x square plus y square plus c by 2. Option B, x is equal to y 10 x square plus y square plus c by 2. And option C, y is equal to x 10 c minus x square minus y square by 2. And option D, none of the above. Okay, so try this question. Try to use the inspection method to solve this. In the theory portion, we discuss some result on the slide of inspection method. So try to recall that result and try to solve this differential equation by using inspection method. Okay, so just try. Anyone? Are you guys trying? Okay, let's solve. So correct answer is option C, that is y is equal to x 10 c minus x square minus y square by 2. So, given differential equation is x dx plus y dy plus x dy minus y dx by x square plus y square is equal to 0. We can write this x dx plus y dy as 1 by 2 d x square plus y square, because we know that when we differentiate dx square plus y square we get 2x dx plus 2y dy, the total derivative. So by using inspection, we write this as 1 by 2 dx square plus y square. And for the block x dy minus y dx by x square plus y square, we write this as d tan inverse y by x is equal to 0. So now we just need to integrate this. So when we integrate, we get 1 by 2 x square plus y square plus tan inverse y by x is equal to constant of integration. We take c as c by 2 for to simplify it. So we get c minus x square minus y square by 2 is equal to tan inverse y by x. So we get y by x is equal to tan c minus x square minus y square by 2. So we get y is equal to x tan c minus x square minus y square by 2. So that's how we can solve a differential equation by using inspection method. Okay, so if we remember all that formula, then we can directly use this formula to solve our differential equation. Okay, simple. Any doubt? Varsha, any doubt? Okay, very good. So that's all for today. Thank you.
Hello students, in today's lecture we are going to learn about electric fields, potential and capacitance. This is theory part first. Alright, this is our disclaimer. So firstly we will talk about the trend analysis. In electric fields, potential and capacitance there is a two chapters, electric charges and fields, and the second one electric potential and capacitance. Okay, so if we talk about electric charges and fields, overall weight is 3.18% according to last 5 years. All right student, and if we talk about yearly question distribution, so we can say in 2024 question asked from Coulomb's law, linear charge density, number of questions 1. And if we talk about their difficulty level, so students we can say question was difficult. In 2023 question asked from Coulomb's law, electric field, number of questions 2, but the difficulty level was easy. Okay, similarly in 2022 question asked from electron charges, number of questions 1, their difficulty level question was difficult. In 2021 question asked from electric field, number of questions 1, and their difficulty level we can say question was difficult. Okay, in 2020 question asked from applications of Gauss's law, number of questions 1, and their difficulty level we can say question was average. Okay, so these are the important concepts which is very important for the exam. If we talk about the chapter electrostatic potential and capacitance, so we can say overall weight is according to last 5 years is 4.49%. Okay, and if we talk about yearly question distribution, so we can say in 2024 question asked from electrostatic potential, number of questions 1, and the difficulty level average. Okay, in 2023 question asked from potential of spherical metallic cell, work done in rotating dipole, number of questions 2, and if we talk about their difficulty level, so we can say question was average. Okay, similarly in 2022 question asked from capacitors, number of questions 1, and their difficulty level average. In 2021 question asked from combination of capacitors, number of questions 1, and their difficulty level easy. Okay, in 2020 question asked from capacitors, number of questions 1, their difficulty level average. Okay, so again these are the important concepts. Okay students, so let's see topics which we will learn in today's lecture. So first electric charge, then we will understand conservation of charge, after that quantization of charge, then we will learn Coulomb's law. There we will discuss forces between 2-point charges or multiple point charges. Okay, then forces between multiple charges, then superposition principle, then electric field, then intensity of electric field E, then electric field lines, and then motion of a charged particle in an electric field. Then we will discuss electric field due to a point charge. And last we will see continuous charge distribution. Okay, so these are the topics which we will cover in today's lecture. All right everyone, so our first concept is electric charge. We will understand the concept of electric charge. electric charge is a fundamental property of matter. Okay, you know what is matter? Matter that occupy space. So the fundamental property of matter due to which an object produces and also experiences electric and magnetic effects known as electric charge. Okay, so let's understand it with the help of an example. So listen carefully. Look at here the diagram. So in this diagram we can see that when a glass rod, okay, when a glass rod is rubbed with a silk thread or silk material, then positive charges appear on the glass rod and negative charges appear on the silk thread. Similarly, when we rub another glass rod with a silk thread or silk material, negative charges will appear on the silk material and positive charges will appear on the glass rod. This means that both the first and second glass rod have the same charges. Okay, that is positive charge. Positive charges. All right. Positive charges repel each other. Okay. In the second case, similarly, when we rub a silk thread or silk material on a plastic rod, okay, negative charges will appear on the plastic rod and positive charges will appear on the silk material. Okay. So when we rub the silk material on another plastic rod, negative charges also appear on the plastic rod when both plastic rods are brought close. Okay. In that case, what happens? So when both plastic rods are brought close, they repel each other. This means that like charges, that is same charges, repel each other. Okay, this is our second case. Now in the third case, when we rub the silk thread on a glass rod, positive charges appear on the glass rod and the negative charges appear on the silk thread. Similarly, when we rub the silk thread on a plastic rod, okay, then and the negative when we rub silk thread on a plastic rod, positive charge appear on the glass rod and negative charges on the silk thread. All right, and when we rub silk thread on a plastic rod, negative charges appear on the plastic rod and positive charges on the silk thread. Okay, so when we bring the glass rod and the plastic rod close, they attract each other. This means that like charges which are similar charges repel each other and unlike charges which are opposite attract each other. Okay, so from this phenomena we can say that like charges repel each other, unlike charges attract each other. Okay, it means suppose we have a two glass rods, okay, or suppose two pencil. Okay, look at here, suppose first one and similarly suppose we have a second one. When on the pen and on the pencil, suppose both the charges have on pen and pencil like charges, means positive positive, in that case they repel each other. And if there is a opposite charges positive or negative, then we can say they are uh, attract each other. So in short we can say like charges repel each other, unlike charges attract each other. Okay, clear everyone? This is the electric charge. I hope the concept of the electric charge is clear. Yes or no? Please answer. Any doubt here? Yes. All right. Now we will study conservation of charge. It is important to understand what conservation of charge means and what is its statement. So, according to conservation of charge, we can neither create nor destroy electric charge. That is, we cannot create electric charge nor we destroy it. Charges can only be transferred from one body to another. This is the concept of conservation of charge. Now, there are three modes of charge transfer, and you know that three modes are by friction. Okay, so first uh, is by friction. Let's see. So in which we transfer charges through friction. Okay, when two charges or when two objects are rubbed against each other, electrons are transferred from one object to another. This causes one object to become positively charged and the other negatively charged. Okay, for example, when a comb is rubbed on dry hair, the comb becomes charged. Yes or no? This is the uh, best example. Clear? And the second is by conduction. So in this method, a charged body is brought into contact with an uncharged conductor. There is a direct flow of electrons, due to which the uncharged body also acquires charge. Here, the transfer of charge occurs through physical contact. And the third is by induction. In this, charge transfer occurs without contact. When a charged object is brought near a neutral body, the charges inside that conductor redistribute. Then, by grounding, a permanent charge can be induced in it. Okay, so these three methods explain how charge can be transferred from one body to another without creating or destroying it. All right, so these are three modes of charge transfer: by friction, by conduction, by induction. Okay, everyone. Now, the next topic is quantization of charge. Electric charge is a quantized. It means that the charge on any object is always in the form of an integer multiple of the smallest unit charge, which is the electronic charge. Okay, E. And the electronic charge is equal to 1.6 into 10 to the power minus 19 coulomb. Okay, this means that the total charge q on any object is always in the form q equal to plus minus ne, where n is an integer. So fractional charge does not exist independently. Now we will discuss important properties of charges. So the first property we can say, like charges repel and opposite charges, or we can say unlike charges, attract. For example, positive positive or negative negative repel each other, but positive negative attract each other. Okay, so this is the first property of charge. If we talk about the second property, so we can say charge is invariant. It means if an object's velocity changes, its charge does not change. And this property also matches with the principle of special relativity. Okay. So according to the theory of relativity, when velocity changes, mass, time and length can change, but charge remains a constant quantity. Next property, uh, a charged body attracts a lighter neutral body because under the influence of charge object, electric field the charges of the neutral body redistribute, leading to attraction. Okay. Next property is electric charge is additive. It means if different charges are present in a body, then the total charge is their algebraic sum. So, for example, if a body has plus 2q plus 4q minus 3q minus q charges, then the total charge will be plus 2q. These properties help in understanding the behavior of electric charge. Okay. Next is Coulomb's law. Coulomb's law tells us how much force acts between 2 point charges. We can calculate the force between 2 point charges through Coulomb's law. If charges q1 and q2 are two stationary point charges placed in free space separated by a distance r, then the force acting them will be F equal to k into mod of q1 into mod of q2 divided by r square, as shown in the figure. Here small r is the distance between these two charges and measured from center to center. Okay. And 1 upon 4 pi epsilon naught is a constant term. The numerical value of k is 9 into 10 to the power 9 Newton meter square per coulomb square. Okay. So just substitute the value in the formula. You will be get some terms. Okay. Now, if a dielectric medium is completely filled between these charges, okay, then in that case we will calculate the formula for Coulomb's law between the charges. So if there is a dielectric medium, then here is a relation between epsilon and epsilon naught. Epsilon is equal to epsilon r into epsilon naught. Here epsilon naught means permittivity in free space and epsilon r is relative permittivity and epsilon is permittivity in medium. So Fm, uh, which means the force in medium will be Fm equal to 1 upon 4 pi epsilon naught epsilon q1 q2 divided by r square, and we replace epsilon with epsilon naught and epsilon r. So Fm becomes 1 upon 4 pi epsilon naught epsilon r into q1 q2 divided by r square. Okay, and the relation is this one, epsilon upon epsilon naught is equal to epsilon r. Okay, this one, look at here. Next is Coulomb's law. Uh, so we know we already discussed Coulomb's law. The relation is this one, F equal to k into q1 q2 divided by r square. Okay, everyone. Any doubt here? Now we will understand how Coulomb's law acts between multiple charges. Okay. When there are multiple point charges in a region, even then the force between any two charges can be calculated using Coulomb's law, and the other charges have no effect on that force. This property is called the principle of superposition. This means the interaction between every pair of charges is independent. Now let's understand this with an example. Here there are four identical charges, each with magnitude q, and each charge is placed at the four corners of square as shown in the figure. Okay, so there is a four charges. Look at it, q, q, q charge, q charge. Okay, so the corners of the square are 1, 2, 3 and 4. So this is a square and the side of the square is a. Okay, look at here, a. Now we will calculate the force acting on any one charge due to we can say due to other three charges. Okay, so the force due to the first charge will be F1 is equal to 1 upon 4 pi epsilon naught q square divided by a square into I cap, because F1 act along x axis, and this term is the magnitude term. Okay, this is magnitude term and this is the direction. And the force due to the second charge will be F2. Due to the second charge is F2. Okay, this one F2. Now F2 is equal to 1 upon 4 pi epsilon naught q square root 2 divided by 4a square into I cap plus j cap. And the force due to third charge, due to this one charge, is F3. F3 is this one. Okay, so is F3. So F3 will be 1 upon 4 pi epsilon naught q square divided by a square j cap. Okay, so these are F1, F2 and F3. Now we will calculate the components of the force in the x and y directions, and both components are equal. So we will get Fx equal to Fy is equal to 1 upon 4 pi epsilon naught q square divided by a square into root 2 by 4 plus 1. And the net force due to three charges will be calculated using F net equal to under root Fx square plus Fy square, and it will be F net equal to 1 upon 4 pi epsilon naught into q square divided by a square into 2 root 2 plus 1 divided by 2. Okay, everyone. Now we will discuss superposition principle. So the principle of superposition means that if a charge is being affected by several other charges, then the total force acting on that charge is the vector sum of all those individual charges, all those individual forces. Okay, that is, the each charge exerts its force independently, and the presence of other charges does not alter that force. Okay, now we will look at some examples of the superposition principle. So assume uh, that there is a force at the origin here, and there are four charges. Okay, there is a three charges q1, q2 and q3. All right, so the first charge is q1. So the first charge is q1, whose distance from the origin is r1. Okay, similarly all right, similarly the distance of q2 is r2. Okay, q2 is r2 and distance of q3 is r3. All right, So R1, R2 or R3 are the distances from the origin of the charges. Alright. So, so the force on that will act on charge Q1 due to the third charge is F13. Okay. Due to the third charge is F13. This one. Look at here in the figure. F13. Okay. And similarly, the force that will act on charge Q1 due to Q2 is F12. All right. And the force on charge Q1 due to third charge is due to second charge is F12. And so the final force is here F1. So F1 is equal to force on the charges first due to second plus force on the charge first due to third. All right. So here, look at here in the figure. F13 force on charge first due to third charge. F12 force on charge first due to second charge. Or F1 force. F1 is the net force. Okay. So here F1 equal to force on charge first due to second plus due force on charge first due to third. So this is the total force when F12 is the force on charge Q1. Okay, similarly other ones. So meanings we can say uh, F1 is the net force. Next is electric field. So what is electric field? If we consider electric field a reason, electric field is a reason due to which a force acts on electric charges. Okay, which is due to an electrical effect. That is when the space around an electric charge q in which another charge q naught experiences a force of attraction or repulsion, that space is called the electric field of charge q. Here charge q is called the source charge, and charge q naught is called the test charge. So the test charge should always be very small so that it does not modify the electric field of the source charge. Now we will discuss what is electric field intensity. Okay, everyone? Clear? So, electric field intensity E is defined as electric force acting on a test charge Q naught placed at a point per unit charge. And if we talk about the formula, so E equal to F divided by Q naught. Here, F is the force that acts on the test charge Q naught. This means if we place a small positive test charge at some point, then by dividing the electric force that acts on it by the charge, we get the electric field intensity. Okay? Electric field is a vector quantity, which means that it has both magnitude and direction. Its direction is always the same as the direction of the force that acts. Its direction is always the same as the direction of force that acts on a positive test charge. If a charge were negative, then the direction of the force and the field would be opposite. The unit of electric field is Newton per coulomb, and is the Newton, and per coulomb is C here. Okay. Any doubt here? All right. But the second unit is volt per meter. It indicates how much force is acting on 1 coulomb of charge, or how much potential difference there is over 1 meter distance. All right. The next topic is electric field lines. An electric field lines is a smooth curve that tangent to which at any point gives the direction of the electric field at that point. Now we will discuss the properties of electric field lines, which are given below. The first property, the point is that electric field lines always originate from positive charge, positive charges on terminate on negative charges. It means electric lines comes out of positive charge and go into the negative charge. No electric field lines intersect each other. It means two electric field lines can never intersect each other. Electric field lines are continuous but they never form a closed loop. Electric field lines are continuous but never form closed loop. Okay. Next is electric field lines cannot exist inside a conductor. Electric shielding is based on this property. Alright. The next topic is the motion of a charged particle in the presence of an external field. Suppose that a charged particle with mass m and charge q, okay, enters an electric field along x-axis, okay, with speed u, all right, and the electric field E is along y-axis, okay. So the force that will act on the charge due to electric field will be Fy equal to Qe, and here the force is 0 along the x-axis, which means the force is always uh, along on the y-axis, okay. And acceleration of the particle along y-axis is given by Ay equal to Fy divided by m. So we know the value of Fy, that is Qe. So just substitute here. You will be get Ay equal to Qe divided by m. And the initial velocity is 0 along y-axis. Uy equal to 0. And the deflection of the charged particle along the y-axis after time t will be y equal to uy t plus 1 by 2 ay t square. So y equal to Qe t square divided by 2m. There is a no acceleration along x-axis. So the acceleration along x-axis is 0. Therefore, the distance covered by the particle in time t along the x-axis is given by u equal to ut, x equal to ut. All right. Now, if we eliminate t, then we have y equal to qe x square divided by 2m u square. So from this relation, it is clear that y is directly proportional to x square. So this shows that the path of charged particle is perpendicular field. Perpendicular field is a parabola. Okay. Electric field due to a point charge uh, and extended bodies. So first, electric field due to a point charge at a distance r. So the formula for the electric field due to a point charge at a distance r is E equal to 1 upon 4 pi epsilon naught q r cap divided by r square. And if q1 and q2 are two like point charges separated by distance r, a neutral point between them is obtained at a distance r1 from q1. In that case, r1 equal to r divided by 1 plus under root q2 divided by q1. All right. If 2 point charges q1 and q2 are given and the distance between is r, so the formula is this one. Similarly, if q1 and q2 are 2 point charges of opposite nature separated by distance r, a neutral point is obtained in the extended line joining them at a distance r1 from q1. In that case, r1 equal to r divided by under root q2 divided by q1 minus 1. Okay. Second is electric field due to infinitely long uniformly charged straight wire. So electric field at a point situated at a normal distance r from an infinitely long uniformly charged straight wire having a linear charge density lambda is E equal to lambda divided by 2 pi epsilon naught r into n cap. Next, electric field due to a charged cylinder. So for a conducting charged cylinder, with linear charge density lambda and radius r, the formula of electric field is E equal to lambda divided by 2 pi epsilon naught r into n cap, for r is greater than r, with radial distance is greater than radius. Now students, all these formulas are very important. You need to remember this. Okay. When r, it means radial distance is equal to radius, the electric field E equal to lambda divided by 2 pi epsilon naught r n cap. Here lambda is the linear charge density, r is the radius of the cylinder, and the epsilon represents permittivity of the medium, and E equal to 0 for r is less than r. Okay. Here small r radial distance at capital R radius. For a non-conducting charge cylinder, uh, E equal to lambda r divided by 2 pi epsilon naught r square, for n r square n cap, for r is less than equal to r, and E equal to lambda divided by 2 pi epsilon naught r n cap, for r is greater than radius. Okay. So there is a variation of electric field with distance for conducting cylinder. So look at here in the figure, in this one. Okay, this figure, and tell me what is meaning of small r is greater than capital R. Think about it, everyone. So this figure shows us the variation of electric field with distance for a conducting cylinder, with the electric field plotted on y-axis, and the electric field here depends on r. Okay. When small r equal to capital R, the electric field is maximum, and when small r radial distance is greater than radius of the conducting cylinder, the electric field becomes inversely proportional to r. Okay. Now for a non-conducting cylinder, the variation of electric field with distance is as follows. So here E is on y-axis, okay, and R on x-axis. Okay. Now from the origin to this point, origin to this point, there is a straight line where R is less than radius. This means the electric field is directly proportional to small r, and electric field is directly proportional to radial distance here. Then uh, when radius equal to radial distance, in that case the E is the maximum. Okay. And when radial distance is greater than radius, in that case electric field is inversely proportional to r square. It means E is inversely proportional to r square. Okay. Electric field due to uniformly charged infinite plane sheet. So here there is a infinitely plane sheet with surface charge density sigma. Uh, Therefore, the formula for electric field near uniformly charged cylinder plane sheet, which is surface charge density sigma, will be E equal to sigma upon 2 epsilon naught n cap. All right. Now we will understand the electric field variation of uniformly charged in spherical cell. So if there is a conducting spherical cell with radius r as shown in the figure and total charge q, then its electric field is, these are some cases when small r is less than capital R inside this sphere or cell, equal to 0, which means that electric field inside a charged cell is 0. Okay. The reason for this is that all the charges resides on the outer surface, and according to Gauss's law, there is a no enclosed charge inside. All right. The second case, when small r is greater than r. Okay. And the third case, here we use this one, graphical representation. So in the second case, the formula is this one, and the graph between E and R is, look at here. At this point, the E is maximum at this point, then inversely proportional. All right. The next topic is continuous charge distribution. Continuous charge distribution means that the charge is uniformly spread out on an object rather than uh, being placed at discrete points. This distribution can be in 1, 2, or 3 dimensions. First is linear charge density lambda. When charge is distributed along a line, whether it is straight or curved, that arrangement is called linear charge distribution. Suppose a thin rod of wire on which a total charge Q is evenly spread over its entire length L. So in that case, the formula for linear charge density lambda equal to Q divided by L. Okay. So to measure the distribution, the term lambda, linear charge density, is used here. It indicates how much charge is present per unit length, and its unit is coulomb per meter. Okay. Second is surface charge density sigma. When charge is spread on area of surface such as a flat plate, the surface of a sphere, or the surface area of a cylinder, then distribution is called surface charge distribution. So the formula is delta Q is equal to sigma into delta S. So sigma equal to Q upon A. A is the area, Q is the total charge, and its unit is coulomb per meter square. Okay. And third is volume charge density rho. When a charge is uniformly distributed throughout the entire volume of an object, for example inside a non-conducting solid sphere, then such an arrangement is called volume charge distribution, and the formula is rho equal to Q divided by V. Okay. And its unit is coulomb per meter cube. Okay. So we discussed in today's lecture electric charge, conservation of charge, then quantization of charge, then Coulomb's law, then superposition principle, then electric field intensity or electric field E, then electric field lines, motion of a charged particle in an electric field, then electric field due to a point charge, continuous charge distribution. Okay. Thank you for your attention. Now students, we will solve some practice questions based on these concepts. So are you ready for the practice question? If yes, write in the chat box. And now here I am expecting answer from everyone. So are you ready for the practice question? Yes or no? Hello students. Now we will solve some practice questions based on electric charges and fields. Okay. So this is our disclaimer. Here we will solve some practice questions based on electric charges and fields. So our first question is two balls of the same mass and carrying equal charge are hung from a fixed support of length L. At electrostatic equilibrium, assuming that angles made by each thread is small, the separation x between the balls is proportional to on what factor? So given options, option A L, option B L square, option C L raised to the power 2 by 3, and option D L raised to the power 1 by 3. So here question asks what are the separation x between the two balls will be proportional to on what factor. Okay, so please solve this question everyone. This is very simple question, and after that we will provide the solution of this question. Okay, please solve. I am waiting your answer. Okay, and tell me the correct one. Yes, Varsha, Karthik, VK, tell me the answer. Anyone? Mark your attendance first. Write in the chat box your names. Yes, all right. VK, okay. So which one is correct? A, B, C, or D? Yes. Which one is correct? B. Option B. Okay. Anyone? Let's see the solution. So the correct option is D. Okay. So firstly, we will understand the graph, or we can say free body diagram. Okay. So as shown in the figure, this ball is suspended from a fixed support by a thread of length L. Okay. Now, due to the weight of this body, tension will arise in the thread. Yes or no? And this tension is capital T, and the body's weight will act vertically downward, that is mg. Okay, where m is the mass and g is the gravitational acceleration. All right. So this weight mg is balanced by t cos theta. Okay. And this t sin theta balances F, which is the electrostatic force. All right. So any and why is this electrostatic force acting? Because there is a charge here, and this charge is q. So the force acting on this body due to this charge is F. Okay. So the formula for F is 1 upon 4 pi epsilon naught q square divided by x square. Okay. And t is the theta, t sin theta will be equal to 1 upon 4 pi epsilon naught q square divided by x square, which is equal to F. Okay. So let this is equation first. And similarly, from vertical equilibrium, equation first comes from horizontal equilibrium, and for from vertical equilibrium, t cos theta as shown in the figure, t cos theta is equal to mg. Yes or no? Look at here, t cos theta, this one is equal to mg, and t sin theta is equal to F. This F is the electrostatic force, student. So just we here substitute the value of F, electrostatic F, electrostatic force. Okay. So let this is equation second. All right. So dividing equation first by second, we get tan theta, which is equal to 1 upon 4 pi epsilon naught uh, into q square divided by x square into mg. Okay. So tan theta will be x divided by uh, 2l is equal to q square upon 4 pi epsilon naught q square x square into mg. This expression. Okay. Look at here, this one. So from this relation, we can say x is directly proportional to ql divided by x square. Yes or no? So when we rearrange it, you will be get x is directly proportional to L raised to the power 1 by 3. And this is our answer. Yes or no? So we find the separation between the balls is proportional to L to the power L to the power 1 by 3, where L is the length of the string. All right? Clear everyone? Yes or no? Any doubt here? Good. Very good. Yes, your answer is correct. Good. Let's see next question. In the basic CSCl crystal structure, CS plus cesium ion and Cl minus chlorine ions are arranged in a BCC configuration. Okay, as shown in the figure. The net electrostatic force exerted by the 8 cesium ions on the chlorine ion is what? So look at here in the figure. There is a 8 cesium ion at the corners of the cube and one is at the center. So you have to find out the uh, net force on chlorine ion. Okay, what is the net electrostatic force on chlorine ion due to 8 cesium ions? All right. Given options: option A 1 upon 4 pi epsilon naught into 4e square divided by 3e square. Option B 1 upon 4 pi epsilon naught into 16e square divided by 3a square. And option C 1 upon 4 pi epsilon naught into 32a square divided by 3a square. And option D 0. So which one is correct? Please answer this question. Yes. Sayyid, please answer. Varsha, VK, please answer. Which one is correct? Anyone? This is a very simple question. Sayyid, tell me the answer. Anyone? Yes, which one? D, option D. Okay, good. Anyone? You just try to solve this question and find out the correct one. Yeah, Sayed, your answer? Which one is correct? Okay. Anyone? So the correct answer will be option D. Yeah, Varsha, your answer is correct. Let's see the solution. Why option D is correct? In this question, it is stated that in a CSCl crystal structure, cesium ions and chlorine ions are arranged in a BCC configuration. Okay, as shown in the figure. So in this figure, we need to calculate the net electrostatic force that 8 cesium ion, yes or no, exerts on chlorine ion. Cesium ions, Cs plus ions, are present at the corners of the cubic structure, and a Cl minus ion is present at the center. So the distance from Cs plus ion to Cl minus ion is equal, and they are diagonally opposite. Okay. So the force acting on the Cl minus ion due to a Cs plus ion will be in this direction. Okay. Look at here, in this direction. Okay. For first one. All right. So similarly, the force acting on the Cl ion due to the another Cs plus ion will be in opposite direction. So the net force balances out in diagonally opposite directions. Okay. So the due to the electrostatic force due to one Cs plus ions is balanced by another diagonally opposite Cs plus ions. In this way, the net electrostatic force on Cl minus ion due to 8 Cs plus ions becomes 0. It means the net electrostatic force on this Cl minus ion should be 0. Okay. Therefore, the correct option is D. Alright, everyone. Good. Next question. A long cylindrical cell uh, carries positive surface charge sigma in the upper half and negative charge minus sigma in the lower half. The electric field lines around the cylinder will look like a figure in figures are schematic and not drawn to scale. Okay. So here in this question, you have to find out the correct one. Okay. How will the electric field lines appear around the cylinder? So which option is correct? A, B, C or D? Please solve this question and tell me which option is correct. Yes, everyone. I'm expecting answer from everyone. Yes, you have some time. Okay, which one is correct? So the correct option is A. Okay. Now we will see among these figures which one is correct. As field lines should originate from positive charge and terminate on negative charge as shown in the figure. Okay, here. This means electric field lines emerge from positive charge and electric field lines emerge from positive charge and on negative charge. Okay, so due to this property, option B and option C are not possible. Okay, B and C are not possible. All right. Now, electric field lines can never form corners. Here in option D, there is a corners. So D is not correct. The remaining is option A. Electric field lines are forming a corner is an incorrect statement. Okay. So option D is incorrect. Therefore, the option A is correct. All right. In A, figure A correctly depicts lines originate from positive charge terminating at the negative bottom. Okay, so figure B shows the lines radiating outwards from our charge, which is incorrect for a dipole configuration. Electric field lines cannot form kinks like a figure D. All right, next question. A positively charged particle P enters the region between two parallel plates with a velocity u in a direction parallel to the plates. Okay, so there is a uniform electric field in this region. P emerges from this region with a velocity v. Take C as a constant. V will depend on u as what? Given options. Option A v equal to cu. Option B v equal to under root u square plus cu. Option C v equal to under root u square plus cyu. And option D v equal to under root u square plus cyu square. So in this question you have to find out the correct one. Okay, please solve this question everyone and try to find out the correct option. Okay, A. Anyone? Okay, good. Anyone? Please try to solve this question. Let's see the correct option. So D option is correct. So when particles enters this region, look at here, this region and travel uh, path L, the speed is in x axis because the particle is traveling in the x axis. Now in the first case here we are only considering x axis, so vx is equal to u plus ax into t. Since acceleration in x direction is 0, so Vx is equal to u. Okay, so T equal to L divided by u, length divided by speed. Acceleration is equal to force upon mass. So we know the force QE divided by m. So in the y direction, y axis, that is the vertical direction, Vy equal to Uy plus At equal to Al divided by u. As we know T equal to L by u, so equation net velocity of the particle will be V square equal to Vx square plus Vy square. V square equal to Vu square, U square plus A square L square divided by U square. Just substitute the value. So it become V square equal to U square plus Cy U square. V equal to under root U square plus Cy U square. Okay. Next question. An infinite line charge produces a field of 9 into 10 to the power 4 Newton per coulomb at a distance of 2 centimeter. Calculate the linear charge density. Okay. We need to calculate the linear charge density. Given options: option A 10 to the power minus 3 coulomb per meter, option B 10 to the power minus 4 coulomb per meter, option C 10 to the power minus 5 coulomb per meter, and option D 10 to the power minus 7 coulomb per meter. So which option is correct? Please find the correct one, everyone, and tell me which option is correct. Which one is correct? Which one is correct? Let's see the solution. So the correct option is D. Okay. So an infinite line charge produces a field which is 9 into 10 to the power 4 Newton per coulomb when uh, the distance x is equal to 2 centimeters is given. So let lambda be the linear charge density. So the distance r equal to 2 centimeter, in meter it will be 2 into 10 to the power minus 2 meter. and we know the value of electric field, that is 9 into 10 to the power 4 Newton per coulomb. So using the formula of electric field due to the an infinite line charge, so E equal to lambda divided by 2 pi epsilon naught r. So just substitute the values, you will be get value of E. So E equal to 2 lambda divided by 4 pi epsilon naught into r. Okay, putting the values we get this one, and lambda should be 10 to the power minus 7 coulomb per meter. This is just calculations. Okay, when we performing calculation, you will be get the value of lambda. Thus the linear charge density is 10 to the power minus 7 coulomb per meter. All right, next question. In a uniformly charged sphere of total charge q and radius r, the electric field E is plotted as a function of distance from the center. The graph which would correspond to the correspond is here is which one? You have to find out the correct graph. We need to find out the graph based on the statement. So which one is correct? A, B, C or D? Please solve this question, everyone. So correct option is C. So for a uniformly charged sphere with a total charge q and radius r, the electric field is plotted as a function of distance from the center. Okay, so inside the uniformly charged sphere, the electric field varies linearly. So the graph is from here to here is linear. Okay, the formula for electric field inside this sphere is E equal to kq divided by r cube into r. And while outside this sphere, it varies inversely, inverse square of the distance. So this is inverse. Okay. So the formula is this one, E equal to kq divided by r squares, and this is also clear from the equation. E is directly proportional to r and E is inversely proportional to r square. Okay, so based on these two concepts, the graph will be look like this. So C option is correct. All right. Next question. Let rho of r equal to qr divided by 4 pi r raised to the power 4 be the charge density distribution for a solid sphere of radius r and the total charge q. For a point P inside the sphere at a distance r1 from the center of the sphere, the magnitude of electric field is what? So here you have to find out the magnitude of electric field. Given options: option A 0, option B q divided by 4 pi epsilon naught r1 square, option C q r1 square divided by 4 pi epsilon naught r raised to the power 4, and option D q r1 square divided by 3 pi epsilon naught r raised to the power 4. So which option is correct? A, B, C or D? Please solve this question, everyone. After that, we will provide the solution of this question. Yes, please solve. Good, good, very good. Good, very good, Varsha. Anyone? Yes. Please try to solve this question. Which one is correct? Anyone? So the correct option is C. Okay, let's see the solution. As we can see that here, there is a sphere of radius r. Okay, and a total charge q, and there is a point p uh, at a distance r1 from the center of the sphere. All right. So uh, according to Gauss theorem, that is closed integration E dot ds is equal to q enclosed divided by epsilon naught. So q enclosed should be integration 0 to r1 rho of r dv. So we know the volume 4 by 3 pi r cube. So just find out the dv upon dr. So it will be 4 pi r square dr. So just substitute the values and take the integration. You will be get q enclosed equal to integration 0 to r1 q divided by pi r raised to r4 into r into 4 pi r square dr. So 4q divided by r raised to r4 take outside because this is constant, and the remaining term is 0 to r1 r cube dr. Okay. So the we have a expression this one. So after performing the integration, you will be get q enclosed equal to 4q divided by r raised to the power 4. After taking the integration, the answer is r1 raised to the power 4 divided by 4. Okay. So when we performing the calculation, it will be q r1 raised to the power 4 divided by r raised to the power 4. So substituting 3 equation 3 into closed integration E dot ds equal to q enclosed divided by epsilon naught, we get this one. Q r1 divided by q r1 raised to the power 4 divided by uh, r raised to the power 4 divided by epsilon naught. So we have an expression this one. So when we rearrange it, you will be get E equal to q r1 square divided by 4 pi epsilon r raised to the power 4. Okay, so this is just mathematical calculations. After doing mathematical calculations, you will be get the E. All right, everyone. Thank you for your attention. That's all for the today. In next lecture, we will discuss more about the electric field charges and capacitance and solve more practice questions that helps you to solve your problem solving skills and build your concept. All right, everyone. Thank you for your attention. That's all for the today. Thank you.